The Milky Way has already collided with other galaxies, and it will collide again. Our galaxy might feel like a stable, unchanging home, a quiet backdrop to our lives here on Earth. But in truth, it is built from the wreckage of others. Over billions upon billions of years, the Milky Way has absorbed smaller galaxies, drawing them in through the relentless pull of gravity, unraveling their structures, and scattering their stars into long, delicate streams that now wrap around our galactic disk, like ghostly ribbons frozen in time. One such galaxy, the Sagittarius Dwarf, is being pulled apart right now. Even as you rest tonight, its stars are being stretched and torn from their ancient orbits, slowly woven into the fabric of the Milky Way. And far off in the night sky, invisible to our naked eyes but measured precisely by astronomers, the Andromeda Galaxy is drifting steadily closer. In about 4.5 billion years, these two great spirals will merge in a cosmic collision unlike anything we can truly imagine. Now, you might think a galactic collision sounds violent, catastrophic even, but in reality, it will be a slow, elegant dance. Stars are so far apart from one another that they will almost never actually hit each other. Instead, the galaxy's shapes will begin to change, folding and bending into entirely new forms. The spiral arms will stretch and warp. Long tidal tails will curl outward into space, and over billions of years, the two galaxies will merge into a single, larger system, vast and quiet, glowing softly in the darkness. Even galaxies, it turns out, are not eternal. They evolve, they collide, they begin again. Some stars in the Milky Way are older than the Milky Way itself. Not every star you see twinkling in the night sky was born here in our galaxy. Some stars, ancient and metal-poor, wandering through the halo in long, tilted orbits, appear to have formed even before the Milky Way had fully taken shape. Astronomers believe these stars may have originated in smaller, primordial galaxies that merged with our own billions of years ago, back when the universe was still young and wild. Their chemical fingerprints tell the story. These stars contain almost no heavy elements, no iron, no calcium, none of the metals that later generations of stars would forge in their cores. This suggests they were born shortly after the Big Bang, when the universe was composed almost entirely of hydrogen and helium. They move slowly and high above the galactic plane, like elder spirits from a time before spirals, before structure, before order. In their ancient light, we glimpse a universe that was younger, stranger, and still learning to become what it is today. These stars are not just old. They are relics, time capsules drifting through space, carrying with them the memory of an era we can barely comprehend. Our solar system orbits the center of the Milky Way at over 828,000 kilometers per hour. That's more than 230 kilometers every single second. And still, even at that astonishing speed, it takes about 225 million years to complete just one loop around the galaxy. This vast, sweeping path is called a galactic year. Think about that for a moment. In all of Earth's history, we've only gone around the Milky Way about 20 times since the solar system first formed. When the first dinosaurs appeared on Earth, we were in a completely different part of the galaxy. The stars we see in our night sky today weren't always nearby, and they won't always remain where they are now. Everything is in motion, quietly, slowly, endlessly. Even as you sleep tonight, the Earth is turning beneath you. The moon circles overhead, and the entire solar system sweeps forward through a galaxy in constant, graceful motion. We are passengers on a cosmic ship, hurtling through space faster than we can possibly imagine. And yet it all feels so still, so peaceful. The galaxy is still growing. Although the Milky Way is ancient, it isn't finished. Even now, at this very moment, it continues to gather material from its surroundings. Gas drifts in from the intergalactic medium, the vast, nearly empty spaces between galaxies. Stars are pulled in from captured dwarf galaxies. Streams of dark matter feed its halo, that enormous, invisible structure that surrounds and holds the galaxy together. It grows not like a living thing, but like a gravitational structure deepening over time, layer upon layer. Some of this growth happens quietly, through the slow infilling of gas clouds that will one day collapse to form new stars. Other times, it comes with disruption, as satellite galaxies are torn apart by tidal forces, their stars scattered across the sky like seeds in the wind. The galaxy you live in today is not the same one the dinosaurs saw when they roamed the Earth millions of years ago. And the one your distant descendants may know, billions of years from now, could be larger still, stitched together from the ruins of 1,000 smaller worlds. The Milky Way is a living, breathing structure, constantly evolving, constantly changing. We don't know how many spiral arms the Milky Way has. It seems like something we should know, doesn't it? How many arms spiral outward from the center of our own galaxy? But from our position deep inside the galactic disk, it's remarkably hard to see the whole structure. Thick clouds of dust obscure distant regions. Stars blur into one another. Perspective becomes distorted. For decades, astronomers believed there were 4 major spiral arms. But more recent observations have suggested maybe fewer, or that the arms twist and split in ways far more complex than we ever expected. Some arms fade into fragments. Others wrap around in unexpected directions. Some researchers have even proposed that the Milky Way may not be a neat pinwheel at all, but a living, layered swirl of stars shaped by forces we still don't fully understand. It's humbling, really. We've mapped distant galaxies billions of light years away, and yet we're still trying to figure out the basic structure of our own cosmic neighborhood. The Milky Way keeps its secrets close. Rogue stars are flung from the core at incredible speeds. Most stars drift calmly through the galaxy, following their orbital paths around the center in a slow, steady dance. But a rare few are flung outward at astonishing speeds, fast enough to escape the Milky Way entirely. These are called hypervelocity stars, and they are some of the most dramatic objects in the galaxy. Some of these rogue stars are the remnants of binary systems that wandered too close to the supermassive black hole at the center of the galaxy. In a violent gravitational encounter, one star falls inward and vanishes beyond the black hole's event horizon, swallowed by the darkness. The other star is slingshot outward, hurled into the void at speeds exceeding 1,000,000 kilometers per hour. These rogue stars travel alone, far from the galactic plane, like glowing comets with no hope of return. They streak through intergalactic space, isolated and adrift, reminders that even in a galaxy bound together by gravity, there are moments of violent release, quiet expulsions that send stars flying into the intergalactic night, never to return home. The Milky Way and Andromeda are on a collision course, high above the horizon, on a clear, dark night. The Andromeda galaxy appears as a faint, hazy blur to the naked eye. It's a spiral, much like our own, lying over 2 million light-years away. And yet, despite that vast distance, it is moving steadily toward us. In about 4.5 billion years, the Milky Way and Andromeda will collide. But again, it won't be violent in the way you might imagine. Stars are spaced too far apart to crash directly into one another. The odds of 2 stars actually colliding during this event are astronomically small, but their gravity will warp both galaxies into long, stretching arcs. Tidal tails will curl outward into space. The supermassive black holes at the centers of both galaxies may spiral together, eventually merging into a single, even more massive black hole. And after billions of years, the 2 galaxies will merge into a single, larger system. Some astronomers have even given this future galaxy a name, Milky Way. It'll be a slow, elegant dance, a gravitational waltz played out over unimaginable spans of time. The future of our home, written across the stars. Some stars orbit backward. Most stars in the Milky Way orbit the galactic center in the same general direction, swept along by the galaxy's overall rotation. But not all follow the rules. Some stars, especially in the outer halo, move in retrograde, orbiting in the opposite direction to the galaxy's main rotation. These stars likely arrived from elsewhere. They were born in dwarf galaxies that were later absorbed by the Milky Way, their orbits preserved like fossils in motion. Their reversed motion is a quiet signature of their foreign origin, a subtle clue to their past. It's as if the galaxy carries old memories in its motion, stories of ancient mergers and cosmic encounters preserved not in light, but in the slow, patient turning of stars against the stream. These backward-moving stars are travelers from other worlds, immigrants in a galaxy built from countless smaller pieces. The Milky Way may have eaten dozens of dwarf galaxies. Over billions of years, the Milky Way has not grown alone. It has consumed. Small galaxies, faint and luminous companions, have drifted too close, been caught in the Milky Way's gravitational embrace, and slowly dismantled. piece by piece. Their stars are now part of our halo, our disk, or long stellar streams that wrap around the galaxy like threads. Astronomers have identified several of these ancient mergers by carefully analyzing stellar motion and chemical composition. One especially large event, called the Gaia-Enceladus merger, added many stars to the Milky Way and may have reshaped the early structure of the galaxy in profound ways. The Milky Way is not a pristine spiral that formed in isolation. It is a composite, a patchwork, built from quiet collisions and stitched together from the remains of many smaller worlds. Every star you see may have a different origin story, a different birthplace, a different journey through the cosmos. The chemical makeup of stars reveals their origin. Every star carries a unique chemical fingerprint, a pattern of elements imprinted at the moment of its birth. By studying these signatures with precision spectroscopy, astronomers can trace a star's history, uncovering where it came from and when it was born. Some stars are rich in heavy elements like iron, calcium, and nickel, suggesting they formed in dense, metal-rich regions where previous generations of stars had already lived and died, enriching the surrounding gas with their remnants. Others are nearly pure hydrogen and helium, born when the universe was still young, before the first supernovae had scattered heavier elements into space. These differences allow scientists to group stars into families, to uncover ancient mergers hidden in the data, and to reconstruct the hidden story of the Milky Way's formation. In this way, chemistry becomes a kind of time machine, a tool that lets us read a star's past like a line of ancient poetry written in light. Each spectrum tells a story, each element a chapter in the long history of the cosmos. The sky is full of stellar streams from shredded galaxies. Across the night sky, thin ribbons of stars stretch in long arcs and graceful curves, barely visible to even our most powerful telescopes, but unmistakable when mapped with precision. These are stellar streams, the remnants of smaller galaxies that wandered too close to the Milky Way and were pulled apart by tidal forces. As these dwarf galaxies orbit, their stars are smeared across space, forming long, delicate trails that trace their former paths through the cosmos. Some of these streams wrap around the galaxy like ghostly halos, barely perceptible. Others dive inward toward the galactic core, their stars slowly being absorbed into the Milky Way's disk. These streams are evidence of past collisions, quiet mergers that built the Milky Way over billions of years. The galaxy, like an ancient tree, carries the rings of its past in every thread of light, every faint stream of stars, a memory of a galaxy that once was. The Milky Way is warped. Our galaxy doesn't lie perfectly flat like a textbook spiral. Its disk bends gently upward on one side and downward on the other, forming a graceful, undulating wave across the stars. This subtle warp was invisible to us for a long time, hidden by our position within the disk itself. But radio telescopes, mapping the distribution of hydrogen gas that stretches far beyond the visible starlight, revealed the truth. Astronomers believe this distortion may be caused by the gravitational influence of satellite galaxies, tugging gently on the Milky Way's edges, like hands pulling at a spinning sheet. Or it could be caused by clumps of dark matter, that mysterious, invisible substance, bending the structure from below in ways we can't directly observe, like ripples spreading across a great spinning sheet. The warp reveals that even galaxies are never fully still, never perfectly symmetrical. Over time, they bend, flex, and change form in response to invisible forces. From a distance, the Milky Way might look like it's dancing slowly through space, its edges rising and falling like the breath of some vast cosmic organism. You can only see about 0.00003% of the Milky Way with the naked eye. Under a clear, dark sky, far from the glow of cities and streetlights, you might be able to see a few thousand stars with your naked eye. To the human eye, that seems like an ocean of light, a vast and endless tapestry stretched across the heavens. But in reality, it's barely a droplet. The Milky Way contains over 100 billion stars. Some estimates place that number even higher, perhaps 200 billion or more. Most of these stars are hidden from view. Some lie behind thick curtains of interstellar dust. Others are simply too faint or too far away for our vision to reach, their light too dim to trigger a response in the cells of our eyes. The pale streak of the Milky Way that crosses the sky on moonless nights, that luminous band that has inspired wonder and myth for millennia, is just the innermost whisper of the whole. We live surrounded by a colossal river of starlight, an unimaginable sea of suns. And yet almost all of it remains invisible to us, too vast to grasp from within, too distant to ever fully comprehend. Stars orbit the galaxy at different speeds. Unlike planets in a solar system, which follow neat, predictable tracks around their central star, stars in the Milky Way move with more freedom, more complexity. Some race ahead in the inner regions, whipping around the galactic center in relatively short orbits. Others drift slowly along the outskirts, taking hundreds of millions of years to complete a single loop. This difference in orbital speed is actually why spiral arms form in the first place. They're not solid structures, not physical objects that rotate as a unit. Instead, they're patterns, like slow-moving traffic jams of stars and gas moving through space. As these density waves pass through the disk, they compress the gas, triggering new bursts of star formation that light up the arms in brilliant curls of blue and white. Our own sun is part of this swirl, moving in and out of these patterns across vast stretches of cosmic time. The galaxy is not a rigid clock, ticking with mechanical precision. It is a current, a flow, a river of stars, and we are drifting gently within it, carried along by forces we're only beginning to understand. The galaxy holds together because of something we cannot see. By all logic, the Milky Way should not exist. Based on what we can actually measure, the stars, the gas, the dust, the outer edges of the galaxy are spinning far too fast. They should be flung outward into space, scattered like leaves caught in a storm, the galaxy unraveling into nothingness. And yet, they remain. The galaxy holds together. The answer, astronomers believe, is dark matter. This mysterious substance does not shine. It does not reflect light. It does not emit any form of radiation that we can detect. But it exerts gravity, and there is so much of it that it outweighs all the visible matter in the galaxy many times over. Some estimates suggest that dark matter makes up about 85% of the total mass of the Milky Way. We don't know what dark matter is. We don't know what it's made of. We can't see it, touch it, or interact with it in any way except through gravity. But we know that without it, the Milky Way, and indeed most galaxies in the universe, would simply fly apart. It is the invisible scaffolding that holds everything in place, the unseen skeleton upon which the galaxy is built. There's a supermassive black hole at the core. At the very center of the Milky Way lies an enormous black hole, a singular point of gravity so intense that nothing, not even light, can escape once it crosses a certain boundary. This cosmic monster is called Sagittarius A*, and it is more than 4 million times the mass of our Sun. Yet, remarkably, it occupies a space smaller than the orbit of Mercury, compressed into an impossibly dense point in space. We cannot see it directly, of course. Black holes are, by their very nature, invisible. But we've watched nearby stars whip around it at tremendous speeds, tracing invisible loops through the void, their motions revealing the presence of something massive and dark at the galactic center. Some of these stars complete their orbits in as little as 16 years, racing around the black hole at speeds approaching a significant fraction of the speed of light. Sometimes, gas and dust fall inward toward Sagittarius A*, spiraling down into the black hole's gravitational well. As this material accelerates and heats up, it flares with X-rays and other forms of high-energy radiation, briefly illuminating the darkness. These flares give us glimpses of the black hole's activity, moments when the invisible becomes visible, if only for a short time. For now, Sagittarius A* sleeps quietly at the heart of our galaxy. It's relatively inactive compared to the supermassive black holes in other galaxies, which can blaze so brightly they outshine every star in their host galaxies combined. But long ago, billions of years in the past, it may have burned like a quasar, lighting up the entire galaxy from within, a beacon of unimaginable energy at the center of our cosmic home. It is the silent conductor of the Milky Way's heart, an invisible maestro pulling stars into a slow, relentless dance that has continued for billions of years and will continue for billions more. The Milky Way has a peanut-shaped bulge. When astronomers mapped the center of the galaxy using infrared observations that can pierce through the obscuring dust, they discovered something quite unexpected. The central bulge of the Milky Way is not a smooth, round ball of stars as many had assumed. Instead, it's shaped like a three-dimensional peanut, or some say, like a rectangular box viewed at an angle. Seen from the side, this bulge swells in the middle and narrows at the ends, like a twisting hourglass made entirely of stars. This strange geometry likely formed from the galaxy's central bar, a dense stripe of stars that rotates slowly through the galactic core. Over time, this bar buckles and puffs upward, creating the peculiar peanut shape we observe today. These inner structures are sculpted by gravity over billions of years, shaped by the accumulated rhythm of countless stellar orbits. The motion of millions upon millions of stars, all pulling on one another, creates patterns and structures that emerge naturally from the mathematics of gravity. We live in a spiral galaxy, but its heart is full of unexpected complexity. Not flat or simple, but intricate and alive with motion. Stellar nurseries shape the spiral arms. The Milky Way's spiral arms are not simply made of stars arranged in pretty patterns. They're woven from the birthplaces of stars, vast clouds of hydrogen gas, dust, and complex molecules that drift through the galaxy. When these enormous clouds pass through the spiral arms, they encounter density waves that compress them, squeezing the gas and triggering the collapse that leads to star formation. These regions are called stellar nurseries, and they are chaotic, glowing, and full of motion. Massive young stars, burning hot and bright, flood these clouds with ultraviolet light, causing the surrounding gas to fluoresce and glow in brilliant shades of red, blue, and green. These bursts of creation trace out the spiral shape, illuminating the curves of the galaxy with quiet fire, painting the arms with the light of newborn suns. Every star in the Milky Way, including our own sun, was born from one of these cloudy cradles long ago. 4.5 billion years in the past, in a stellar nursery much like the ones we observe today, a cloud of gas and dust began to collapse. Within that collapsing cloud, our sun ignited, and around it, the planets of our solar system slowly took shape. We are children of the spiral arms, born from the same processes that continue today in regions scattered throughout the galaxy. The Milky Way is surrounded by a vast halo. Beyond the flat spiral disk that we typically picture when we think of the Milky Way lies something far more diffuse and far larger, a spherical halo that surrounds the entire galaxy like an enormous, invisible bubble. This halo contains ancient stars, globular clusters, and vast amounts of dark matter. Though it is nearly invisible to our telescopes, this halo may actually hold the majority of the Milky Way's total mass. The stars in the halo are spread thin across vast distances, orbiting in long, slow arcs that rarely bring them close to the disk. They move on paths that can take billions of years to complete, wandering through the outer reaches of the galaxy like solitary pilgrims. Many of these halo stars are incredibly old, formed in the earliest epochs of the galaxy's history, and they carry with them chemical signatures from a time when the universe was fundamentally different than it is today. The halo also preserves the remnants of ancient galactic mergers, streams and shells of stars torn from smaller galaxies and left behind like cosmic fossils. When a dwarf galaxy falls into the Milky Way, its stars don't simply disappear. They're scattered into the halo, forming long trails that astronomers can map and study. Each stream tells a story of a galaxy that once was, now dissolved and absorbed into our own. It is the galaxy's outer memory, quiet and dim, but still in motion, still shaping what the Milky Way becomes with each passing epoch. It contains over 150 globular clusters. Globular clusters are among the oldest and most beautiful objects in the galaxy. They are compact, spherical collections of hundreds of thousands of stars, all bound tightly together by gravity. These clusters orbit the galactic center in the halo, moving in long elliptical paths like moths circling a distant flame. Some of these globular clusters are incredibly stable, having survived for more than 12 billion years, nearly as old as the universe itself. Many contain stars that predate the formation of the Milky Way's disk, ancient suns that were already shining when the galaxy was still assembling itself from smaller pieces. Their stars are metal poor, meaning they formed before the universe had time to create many of the heavier elements we see today. They were born from gas that was nearly pure hydrogen and helium, the primordial ingredients left over from the Big Bang. Globular clusters serve as time capsules, holding crucial clues about how the galaxy formed, what smaller galaxies it consumed in its youth, and what conditions were like in the early cosmos. By studying the ages, compositions, and orbits of these clusters, astronomers can piece together the history of the Milky Way's formation, working backward through billions of years of cosmic evolution. These quiet golden spheres drift patiently above and below the galactic plane, glowing softly in the darkness. Monuments to an ancient era, when the universe was young and the first stars were just beginning to light the void. You are floating within it all, a small warmth in the darkness, resting gently in the spiral arm of a vast, radiant galaxy. Sleep well, and let the quiet wonders of the cosmos carry you softly into your dreams. Good night.